Alright guys, I'm going to be working through some of these examples. I'm going to do one page per video, which is going to be 4 or 5 problems. If you want to fast forward to the problem you're looking for, feel free to do so. So number one, we've got an integral, and what I want to do first is simplify. So I'm going to get x to the 3 halves plus x to the 1 half. And my antiderivative is going to be x to the 5 halves with a coefficient of 2/5 plus x to the 3 halves with a coefficient of 2/3 evaluated at 0 and 1. That gives me 2/5 plus 2/3 minus 0 plus 0. And I've got a common denominator here. This is 6/15 plus 10/15, which is going to be 16/15. So your answer for number 1 is C. All right, number 2 is an example of a parametric equation. That's something we haven't covered yet. We'll be coming back and doing that in a little bit. All right, on to number 3. We've got a max-min problem. Hopefully the first thing that comes to mind is a derivative. So I'm going to take f prime, and I get 15x to the 4th minus 12x squared minus 3. I want to find my critical numbers for this function, so I'm going to set the derivative equal to 0. Factor out a common factor of 3. That leaves me with 5x to the 4th minus 4x squared minus 1. And in factored form, that's going to be 5x squared and x squared. And I have a plus 1 and a minus 1. That leaves me with 5x squared plus 1 equals 0, which has no real solutions, and x squared minus 1 equals 0, which has solutions of plus or minus 1. We're going to do our sign analysis. At -1 and 1, if I go back to the factored form of the derivative, I get 0 for either of those values. Anything greater than 1 is going to give me a positive. Anything in between -1 and 1, like 0, is going to give me a positive and a negative. And anything to the left of -1 is going to give me a positive and a positive. And since this is a maximum problem, I'm looking for a positive changing to a negative. That makes -1 our answer, and that's A. On to number 4. Number 4 is another derivative problem. I should notice here that I could use the product rule. However, I have something that can be simplified, which is going to make my life a whole lot easier. E to the natural log of x squared is actually just x squared. And if you see that, that makes this problem a very easy one. And you get 3x squared. C is your answer for number 4. Okay, on to number 5. I have another derivative here. This one cannot be simplified, so I'm going to jump right in with the derivative. I've got 3 halves, x minus 1 to the 1 half. I should be thinking chain rule here, but the x minus 1 has no derivative, so that's as far as I can go. The derivative of e to the x minus 2 is itself. Again, chain rule would be appropriate, but x minus 2 has no derivative, or derivative of 1. And so my derivative looks like that. Plugging in 2, I get 3 halves times 1 to the 1 half plus e to the 0 over 2. 1 to the 1 half is just 1, so this gives me 3 halves plus 1 half, and I get an answer of 2. C is your answer to number 5. And we've got number 6. Question about a normal line. We should remember that a normal line is simply perpendicular to a tangent line. So I want to find the tangent line first by doing my derivative. Careful of the chain rule here. You do have a times -1. So my derivative is going to be -1 over 2 square root 16 minus x. When I plug in 0 to that derivative, I'm going to get -1 over 2 times the square root of 16, which is -1 over 2 times 4, which is -8. That is the slope of my tangent, but I'm asking for the normal slope, so I want the perpendicular, and that's going to be 8. A is your answer to 6.